acid causes the low in, definitely when you have a more acid, there is a low pH. Low pH and color is the mannitol salt environment basically particularly use it for Staph aureus because Staph aureus can grow in higher salt concentration. And also by this way you differentiate between the different strains of the Staph aureus. Finished media, okay? Blood agar, McConkey, and this. Now these are the enzyme tests. What is the first test? What is the first test? What is the first test here? First enzyme test is called catalase. It's called catalase. If bacteria having the presence of enzyme catalase, if bacteria having inside the bacterial cell there is presence of enzyme catalase, it will break down hydrogen peroxide into water and oxygen. Catalase enzyme is an enzyme. Catalase is an enzyme present in the, not in all bacteria, some bacteria. The property of catalase. What is H2O2? What is H2O2? Hydrogen peroxide. And if the bacteria having the enzyme catalase, it breaks down into water and oxygen. It breaks down into water and so by this way, in our body cells, if there is an infection of the bacteria and body cell releases the hydrogen peroxide to kill that microbe, cell produces hydrogen to kill that microbe. If microbe is having the presence of this enzyme, the bacteria releases this enzyme immediately to destroy the hydrogen peroxide. How? In the form of water and oxygen. You see bubbles? It is positive. And the second is negative. This means the microbe is not having the enzyme. Is not having the enzyme of catalase. Now you see on this slide here, in this slide, I have put the drops of the hydrogen peroxide, okay? Now, here is a culture of a bacteria, okay? Now, I will show you that this microorganism contains an enzyme catalase and it will break down hydrogen peroxide into water and oxygen. And when we do like this, you see here, bubbles coming out. This means this bacteria has an enzyme catalase. It breaks down the hydrogen peroxide into. You see bubbles coming out. Keep it at here. Now after 2 minutes, you will see. After you see in the beginning of the lecture, I did you see it looks like this. Bubbles. This means this bacteria has a capability to break down catalase. To break down, it has a capability to break down hydrogen peroxide into water and oxygen. And that time, when bacteria do like this, then at that time it's called catalase positive bacteria. It's called like Staphylococcus, E. coli, they are catalase positive. We are getting late, huh? And second is coagulase. This is one enzyme, okay? Second enzyme is the coagulase. Coagulase is also the property of some bacteria like Staphylococcus aureus. Always remember, Staphylococcus aureus is the only bacteria which is catalase positive and coagulase positive. Many bacteria can be catalase positive, but Staphylococcus is catalase positive as well as coagulase positive. What is the function of the coagulase? Coagulase is an enzyme released by the bacteria. It causes fibrinogen. It converts fibrinogen into fibrin and in the form of clot. You see here, this is serum, and we have inoculated bacteria. There is no reaction, but in this case there is a clot at the bottom. So this means the bacteria is coagulase positive. So some bacteria are coagulase positive, some are coagulase negative. Example is, the best example is Staphylococcus aureus. It is coagulase positive.
And catalase all the staphylococcus, all the types of staphylococcus?
No, Staphylococcus? Yes. Staphylococcus catalase positive.
All the staphylococcus aureus, pneumonia.
Catalase positive. But I just make it very simple. You can write only one. You can write the E. coli, okay? Or if you write Staphylococcus aureus, okay. Fine, okay? Understood? Fine. So it is catalase and coagulase. Actually, meanwhile, I forget to tell you what is the principle of this test. Principle. Number of times I ask the students write the principle. The principle of catalase is very simple. For example, what's the principle of this catalase test? You will say the principle. It is an enzyme that breaks down hydrogen peroxide into water and oxygen. This is the principle. Principle for coagulase. An enzyme that converts solid fibrinogen into the fibrin. This is the principle means how the reaction occurs, how it works. Oxidase. Oxidase is also an enzyme, cytochrome enzyme. It transfers the electrons to the oxygen and form water if microbe is aerobic respiration. Okay? And it looks like blue in color upon the reaction. Oxidase enzyme confirms that there is presence of cytochrome oxidase. You heard about something about cytochrome oxidase? In the biochemistry, you read the cytochrome oxidase play an important role in the mitochondria for aerobic respiration. But in bacteria, there are no mitochondria. On its surface of the bacteria, inner membrane of bacteria, there are presence of the cytochrome that plays a role. To confirm this enzyme, there is a test. It looks like purple in color. And finally, one more test is the urease. Some bacteria have the enzyme urease. What is the property of urease? Very good. It's the urea. Some bacteria have a capability, they break down urea. They break down urea into ammonia and carbon dioxide. This is the breakdown. It becomes the carbon dioxide, ammonia is released by presence of enzyme urease. One of the best examples for the urease is Protease. Protease secretes an enzyme urease and it breaks down urea into ammonia and carbon. So what is the principle of this urease test? Enzyme that splits urea molecule into ammonia. Pink color is a positive test. Because we have one more lab, I think. That day I will tell you pyloric infection, Helicobacter pylori, how it survives inside the acid content because of this enzyme. You know, what is the ammonia? Is the acid or a base? Yes. Correct. Ammonia is a base. Urea is not a base, okay? Urea is not a base. If bacteria is present, it breaks down ammonia, it creates the ammonia and carbon dioxide, more basic content is formed in your body. It can increase the base environment, it will increase with the help of, if this bacteria, enzyme, like this bacteria Protease, if it is present, it can cause. And also the only microbe that can travel through your urinary tract to the kidneys, it can cause stones. Why? Because of presence of urease enzyme. It forms the base inside your kidneys, the accumulation of ammonia with salts and result in the formation of a kidney stone. Usually you haven't heard that microbe causes the kidney stone, but Protease causes. Why? Because Protease is a urease positive. Motility test is very simple. It shows whether bacteria is having flagella or not. Okay? But it should be done here. It is just, you remember this hanging droplet. It is purpose of a motility test is to see whether bacteria is having flagella moving or not. Now, these are 4 biochemical tests. Indol, methyl red, and one more is voice posture, then we will close. You see the indol test? The purpose of indol test, tryptophan, what is tryptophan? You see here, there is here in this tube, there is presence of tryptophan, there is presence of, if bacteria breaks down the tryptophan, if it breaks down, it will form indol. It will form with the help of enzyme tryptophanase. If bacteria is having the enzyme tryptophanase, it will break down indol and it will break down tryptophan and form the indol. Indol is a ring-shaped compound. You see the ring is formed on the top. The ring is formed positive in the indol test. Why this ring? This means if this ring is formed, this means the bacteria has the presence of enzyme tryptophanase. It has broken down the tryptophan into indol, and indol forms a ring. Next day you will see there on the after culturing, you will see it is present here. Okay? Understood indol? What's the indol test? Bacteria breaks down the tryptophan amino acid into indol. Indol is a ring shaped. Why it breaks down? Because the bacteria has presence of the enzyme tryptophanase. Next, methyl red. Methyl red is a test to see whether bacteria ferments glucose or not. If there is presence of glucose, okay, if bacteria ferments the glucose, it will produce acid. It will produce acid. The pH will decrease, low pH, and color will be like this. Okay? This is ability of a bacteria to produce acid as the end point. At the end, the bacteria, after the fermentation, after utilizing the glucose, if bacteria produces acid, it causes the low in pH and it indicates the positive test. Fine. Go to the next. What is this? Again, what is prostate? If bacteria, here it produces acid, okay, like lactic acid. If bacteria produces neutral product, what is a neutral product? Neither acid nor base. Neither acid nor as an end product, then color is, it is pinkish, but it's not here clear. It looks like pinkish in color. In the citrate here, citrate test. Sometimes bacteria cannot use carbon source except citrate. Except it utilizes only citrate as a source of energy. This is blue in color. Citrate, blue in color. Okay? Fine?
How is this one?
Which one?
What is the name of it? This is the photo.
Voice Prosker.
This is the name of the gap?
No, name of test.
So what's
Like-
this test? Identify
You
the
see,
Oh,
in
that's
the,
just the
you
test.
see in methyl red,
Yeah.
the end product is acid. Okay?
Yeah.
End product is acid. Here in Voice Prosker, the end product is acetoin. Acetoin is a neutral product. This is the difference. Neither
Oh.
acid nor base. Okay? This is a combined test, whether bacteria is fermenting sugar, lactose or this. Just simply remember, if it is pink, this means bacteria has fermented the sugar. If it is black, this means bacteria having the presence of hydrogen sulfide. Okay? Hydrogen sulfide for black color. Black, these two are very important here. Important in the sense, pink color for glucose fermentation, black color for hydrogen sulfide production. We have discussed this. Glucose, lactose, sucrose, these are fermented. Either it may be acid with gas or neutral product. This is antibiotic sensitivity. Now see at the end here in the antibiotic sensitivity. What is written here, one? I have put in this picture 1, 2, 3, 4, 5, 6, 7, 8 antibiotic discs are present. and this is the growth of bacteria. Here there is no growth. There is no growth. There is growth but little. Very little growth. Very little growth. No growth. I'm sorry. I said it the reverse. There is growth. There is no growth. There is also no growth, but of different sizes. Okay? What does it mean? Number one. There is no growth of the bacteria. This means the bacteria is sensitive. This antibiotic can kill the bacteria. What's number two? Little bit. So we can call it intermediate. We can call it intermediate. What is number three? It is completely, this antibiotic is a failure. So this is the main purpose of the antibiotic, because you know, doctors are not angels, okay? They cannot say this antibiotic can kill until they will not do this test. You have to use different kinds of antibiotics. By that way, you can find which of the antibiotic most effective. You see, out of 8, how many is effective? Only 1 and 1 written. Rest is of no use. So when doctor see the report, he will pick up number 1 antibiotic, the written number 1, he will give the patient, and he will recover after taking the proper course of medicine. This is the serology. Serology means antigen and antibody reaction. Antigen and antibody. What is this? What is this? What is this?
Antibody.
Why? Who said this is why? This is antibody, okay? This is antibody, okay? Now tell me, what is an antigen? First, what is antibody?
Killing bacteria.
What is antibody simply?
It's a protein.
It's a protein produced by plasma cell. What's a plasma? B cell. B lymphocyte, they produce whenever person is having an infection, body immediately responds to that infection. It produces the plasma cells. Plasma cells are called the immunoglobulins, antibodies. Various types of IgG, IgM, IgG, D, E, so many, okay? Then this is called the antibody. And what's called the antigen? What's the antigen? Define antigen. Okay. Antigen is a substance that stimulates your immune response. When it stimulates the response, immediately the antibody will come and attack. Purpose of antibody is to eliminate the antigen. It can be a bacteria. It can be not only this. Sometimes bacteria affect the cell. Cell release some proteins that act as antigens. If this antigen and antibody react together, okay? If this antigen and antibody react together, it will form clump. It will form, you see here, you will have like this test. You put this either antigen, fix it on the slide, antigen, and you put the serum on it, and you check the reaction. Or sometimes direct the blood. Blood is one of the best examples of the blood grouping. A positive, B positive, B negative. This means there is a reaction. So here is one more example for Treponema or Salmonella typhi. You see here in the above blue color, there is no clumping. Where you see the clumping? In number 3, number 2, number 5, and little in number 4. This means there has been a reaction of antigen and antibody. Reaction of antigen and antibody. Forget about this picture. What is this picture? This is in vitro test. Methyl red test, like you see, glucose test, sugar test, urease test, all tests together. So we have discussed them one by one. This is a machine. You give the machine to you insert directly this culture plate, and it identifies, okay? Antibiotic sensitivity, rapid identification, and it forms the antimicrobial susceptibility test. This will not come in the exam, but this is just for the understanding, okay? That this is a machine that can identify the microbe as well as it can help us to choose the antibiotic. Antibiotic sensitivity can be done by using this machine. and this is the polymerase chain reaction. Polymerase chain. This is biochemistry. You had a lecture on PCR, polymerase chain reaction. This is our last slide. The polymerase chain reaction, it is a molecular method used to amplify single copy of or a few pieces of a DNA in order to generate millions of copies. Maybe it will come. Sometimes you have an infection that cannot be identified. For example, tuberculosis. It is very difficult to find because you will not usually find the microbe, but if you do the PCR, it will identify the DNA of the bacteria. This is the DNA, okay, of human body. Important things in the PCR. Important things in PCR. First, we need the primer. What is the primer? No. Primer is a short sequence of bases. Short sequence of, what are the bases? Correct. Adenine, guanine, cytosine, thymine. These are the 4 bases. Our structure, what is based on these bases? Our DNA, adenine, guanine. We need a primer. Primer is a short sequence of these bases. We need nucleotides. What are nucleotides? Nucleotides are adenine, guanine, cytosine, thymine. Okay? Money, we need them all. And we need, what is the DNA polymerase? Finish. In the PCR, you need 1, 2, you need primer, you need nucleotides, you need DNA polymerase. Remember for your whole life, how you can remember, you can do the PCR. But all these steps, they need different kind of temperature. At the first step, this is the DNA. We are suspecting the patient is having some kind of infection and we isolate the sample. Maybe there is presence of the DNA, this piece of DNA. The first step in PCR, you will separate this DNA. You will separate in 2 lines, okay? How we separate it? By heat, okay? They are separated. Now in the next step, in which direction primer works? Primer works into 5 to 3' direction, and you add the primer. I will explain you why we need the primer in PCR. Why we need a primer? For example, I have to put the switches on. What I need? I need support. I need the support. So in the beginning, I told you in the PCR, we need primer, we need nucleotides, we need DNA polymerase. When we separate these 2 things, we have the nucleotides, we have adenine, guanine, cytosine. But how we bring them here to attach here? For that we need the support. We use the support, the primer. Primer fixes here. Okay, this is DNA in 2 steps by heat. Next step, primer will come, it will bind here and here. What we see in the next step, this is the DNA, okay? This is the primer, okay? Now, this primer will come with the help of DNA polymerase. The bases will come and they will join here. Understand? Did you understand? And this is an enzyme. Enzyme is called DNA polymerase. And here also enzyme. This is the purpose of PCR. You see 2 bands. But now here, what you will have, these 2 bands plus these 2 bands. So DNA is increased. So in the PCR, if you have a single copy of a DNA, you can make millions of the copies. Why? You need the primer. If you have a primer, you have a nucleotides, you have a DNA polymerase enzyme, you can do the PCR very easily. PCR machine is there. But we have never performed PCR reaction here. So first step here now, see here. This is the primer. What is the job of primer? To act as
Starting
starting point. These are the nucleotides. You see first DNA separated. Here the primer is fixed. With the help of the enzyme DNA polymerase, it catches other nucleotides attached here and number of copies are formed. This is called as a PCR reaction. So when you have the number of the DNA, in the beginning you are suspecting the microbe only single piece of DNA or 2 pieces, but now using the PCR you will have a number of copies and it becomes easy to identify the microbe. Thank you so much for your time.
Thank you.